So today we're talking about weight and mass. Is an object's mass the same thing as an object's weight? No, of course not. Mass is how much measure an object has versus weight. Another name for that is force of gravity. So examples of how they're different: if you're in deep outer space, you're considered weightless, but you still have mass. If you're standing on the moon, you weigh less, but your mass is exactly the same as if it was on the Earth. So the unit of mass is a kilogram. Uh, Abbreviation is kg. The unit for weight is newtons, just like every other force, and abbreviated with a capital N. And the US, we use pounds. We're not going to calculate pounds. I just wanted to make a connection there. So G, this is not an earth-shattering variable here, but we haven't used it yet. And this is the magnitude of the acceleration of gravity. The value of that is 9.8 meters per second squared. But catch this, it is just the absolute value of the magnitude, of the acceleration of gravity. So it's not negative 9.8 meters per second squared, just 9.8 meters per second squared. So weight and mass, they are related. As you increase the mass, you're going to have more weight. So there's got to be an equation that converts the two. And that is the force of gravity, or weight, is equal to mass times 9.8. So if you had 4 kilogram pumpkin, you take 4 kilograms, multiply that by 9.8, and get 32.9 newtons. That's how much a 4 kilogram pumpkin would weigh in newtons. So just to make a connection between things you might be familiar with, 1 kilogram is considered 9.8 newtons. That just from our equation we just looked at. 1 pound is 4.45 newtons, so like roughly 4.5 newtons for every 1 pound, and 1 kilogram is 2.2 pounds. So just to make some connections there. So do your pre-quiz.